Okay, our Chapter 13 is our last chapter that we're going to do this unit, and so the next class we're going to do the chapter review. We'll do the Chapter 13 quiz and then review, and then there'll be the test after that. And so what I really want to first try to do is summarize the difference between Chapter 12 and Chapter 13 so that you can keep those concepts separated from each other. And so I'm going to kind of give you a summary right here. And then we're going to get to do something with McClellan's Magnificent Magical Mints. And then I'll give you the Chapter 13 notes, where if you have gone through the discussion, if you've paid attention and gone through the discussion with me, then filling in the Chapter 13 notes, which is very, very vocabulary driven, will just kind of fall in place, and hopefully you'll be able to kind of just fill them all in. Okay, so here we go. So first of all, in Chapter 12, we did sampling. Okay, and y'all just took the quiz on that, and so we did all the different types of samples. When we did our bear hunt, we were going along and we were trying to find a sample of the bears in 1 square mile, and then we were hoping to do what? Generalize it for the whole entire population. Okay, so that's what sample does for us. Is our goal is to generalize it for the whole population. Whereas observational studies and experiments, we can't generalize to the whole entire population. We're just trying to see if there's a difference in the effects of 2 different treatments, medicine A versus medicine B, medicine A versus a placebo, the sugar pill, whatever. Okay? So they really are, they're designs that do 2 different things. And if you do not understand this fundamental difference up front, then come AP time when those, or even our tests, when those start kind of mixing in together, you might get confused as to if you need to do a sample survey or if you need to do an experiment. Okay. Now that I've talked about those, let's go down and look at the difference between the 2 things in Chapter 13, which are observational studies and experiments. Okay? Observational studies typically occur and the goal is to find a relationship, just like find a relationship between things. You usually cannot with these say that you have a cause and that you have a definite effect. You cannot do that with studies. For example, if I say, and the example that the book gives you, and so then when you read this, this is what you'll follow. If I say that taking music classes will help you do better in school, or you'll perform better in school, get A's or whatever, then can I really prove that? There's lots of other things happening, isn't there? What other things do you take into account because of the if you're in music, then you probably also have what? A good home life. Yes, supportive parents. You have the money for music lessons. So does that mean you also have the money for computers that will support, doing well on your schoolwork? Okay. So there's too many things. How can you differentiate between those 2? So typically we'll do a study just to make an association between the 2 things. Okay. There's a retrospective study, which would be looking back. So I now know all the kids who make A's, and I'm going to go look back and see how they did if they did better when they started taking music lessons or whatever. Versus prospective, that would be, I'm going to identify all the kids in 6th grade that are going to take music, and then I'm going to watch them forward from here on out, so going forward. Okay. This sometimes doesn't work out because of anecdotal evidence. Like if I wanted to look back at the medicine I was taking last year and tell you how many seizures I had because of that medicine, then, that's not necessarily a reliable source. Okay? So when you're dealing with people remembering things, what they had done, not necessarily reliable data. Sometimes useful, sometimes it's the worst of both worlds because it does not Since it's not based on random samples like sampling, and it doesn't create a treatment. Okay? For example, I cannot say to a collection, I have 100 pregnant women, and I cannot say, okay, you 50, I want to see if alcohol affects the baby. I cannot say, okay, hey, you 50 people, I want you to not drink alcohol during your pregnancy. And then, okay, you 50 random people over here, I want you to drink, 5 servings of alcohol every day. And then we're going to see if it affects the baby. Okay? That would be a controlled experiment. I could control that experiment, but is it ethical? No. Therefore, I have to have a study about it, and it would probably be retrospective or not necessarily. Maybe I identify people and I ask them, what's your alcohol intake, and and then I take a study based on that. Okay? All right. Because it's not a study, you cannot generalize for the entire population, and because it's not an experiment, you cannot do cause and effect. So observational studies are very limiting, but in some cases necessary because of ethics. Is that a good summary? All right. Whereas experiments rarely allow for generalizations. That's what samples do. Now, medical people try to do that all the time. Don't they perform medical experiments and then try to say to the FDA, hey, look, you should approve our drug because we've done so many experiments with thousands of people. We suppose that it's going to work that way for the whole population. Okay, so they try to generalize. Okay, but the most important thing about experiment is that it can definitely give us, when done correctly, a cause and an effect. You are going to get a magical mint, and we're going to see if that affected your test score. All right? You should control what you can control, and we'll go through an experiment demonstrating that. Randomize the rest. Repeat as much as necessary in hopes that you can make a generalization. Blocking sometimes comes in and is helpful. Not all experiments have to have a blocking design, but you might want to. For example, let's say I have a blood pressure medicine that I want to see the effects of it. I have a thought that it's possible men would respond differently to the medicine than women. So, you know what I would do? I would block them first. And I'd put all my men in a group, and I'd do a control group and a medicine group with them. I'd put all my women over here in a block, and I'd give them the medicine, and then there'd be a placebo group. See how the women did. Come over here, see how the men did. Compare those results, okay? Maybe I even want to see, is this better for men than it is for women? Maybe it's not good enough for men, but it is for women. Maybe I could compare those two together. All right. Do you know how we talked about stratifying and sampling and putting into groups? In sampling, you stratify, but in experiments, you block. So if you're taking a sample, then that's called stratifying. But if you're doing an experiment, then that's called blocking. All right, so there's some basic vocabulary stuff going through and the overall general concepts of where you're headed and what we're doing. Vocabulary is essential in this lesson. Okay, so guess what? We're going to now talk about an experiment. Okay, so here we go. We're going to talk about McClellan's magnificent. Oh, that says marvelous, and this says magnificent says off, but that's okay. Magical mints, okay. So I'm going to do this, and then I'm going to sell these, but I'm going to have an experiment and see what claim I can make. Here's what I want to claim. I pose that the mints improve your test scores. Okay? Wouldn't you buy, would you buy that or what? Absolutely. I'd have like a whole drawer full. Okay. On hand every day. All right. So guess what I'm going to do? I figured it out. Okay. I'm going to give you all the magical mint. And then when you take your test this next class, see, it's kind of like an everlasting gobstopper. It'll work forever. So you maybe only need one. But maybe you need a booster shot every once in a while, so you keep a couple. But so I'm going to compare this. I'm going to compare your results on your next upcoming test to how you did last year on your tax test. Okay, so what do you think about that? Is that a good, that's a good design so I can figure out my cause and effect? No? Okay. AP is harder than tax. Okay. So that's not a good comparison? Ah, okay. It's like, okay, very good. Is it like apples and oranges? Kind of uncomparable baselines? Okay, so that's out. All right, let's see what else. Let's see how else could I organize this. Okay, so I'm going to give the magical min to all of you guys in here, and then you're going to take the chapter test or the unit test, and then I'm going to compare your results to all my other stats classes results. What do you think about that? Okay? Okay, we're getting better, aren't we? Okay? All right, good. So that looks pretty good. Oh, interesting. We don't know how good this class is in general to my other classes. Also, let's see, maybe I was absent on an A day. So guess what? They didn't get the same instruction as you guys. So that might mess things up. If y'all are just my super smart class anyway, because, man, I have just had my conference period. I'm coming in here refreshed, ready to teach. You guys get the best teaching. But my other ones, especially when I was absent one day last week, so is it fair to compare this class against my 2A? No. Okay. So better direction, but I didn't control all of the varying factors. I think I can control it better. Okay. What if I did this? What if I go ahead and just maintain it inside this class, so that way I know you all have the same instruction and everything. I give half of the class the magical mint, and half of the class dum-dums. Half of you guys dum-dums. You want a dum-dum? You don't want the magical mint? Are you sure? Are you sure? Look, they're real pretty. They're pretty. Look, they even have the little M to the 4th. McClellan's magnificent magical mints. Look, they're. No, I made them. Yes. Okay. All right. What do you think? Don't you want a magical mint now? Okay. Well, don't you want it because you think it's going to improve your test score? Okay. So what if I go ahead and I give half of you a magical mint and half of you a dum-dum? Here, let's do that. Okay. So I'm going to randomly choose half of you. Oh. Woo! Okay, randomly. Randomly, I'm giving half of you guys my magical mints. And then half of you guys, I should have done like 2 per table. Okay, so then here's another one for that table. Oh, man, sorry. Okay, oh, there we go. One more here. One more back there. Jake, you get one. Okay, so half of you got magical mints, and half of you are going to get dum-dums. So don't complain about the flavor. Here we go. Shrimp flavor. There is a new flavor. It's coconut. Oh, man. Yes, you can have them. All right. Everybody got something? Okay. So guess what? Half of you have dum-dums, half of you have magical mints. Let's have the test. Okay, what do you think? Yeah, I guess so. I don't know. Okay. Well, what do you have to say about that? Is that a good design? Because see, then I can tell, then I can say, oh, you know what? I know Rebecca got the magical mint. I'm expecting Rebecca's test grade to be better. Oh, but because I randomized it, I know that half of my group has about the same test average as my other half of the class. Okay, because I randomly did that. So I know that because I randomly put half here and half there, we're going to have an overall average the same in those. So what if the overall average of my magical mints is higher than the dum-dums? Okay, what do you think? Is there any problem with that design? Is that good? I should go for it. Okay, there's a problem, so start figuring out. Some people need to not have anything. Okay, well then they can just have nothing and I'll put them in the dum-dum group. So it's either you got the magical potion in the mint or you didn't. Okay? All right, so now what? No, we're not taking a test yet. Because y'all can't figure this out. What's wrong with that design? Oh, I need a retest. No. What? There is a flaw in this design. What is it? Yes, I'm saying that people that have a magical mint are going to make a better grade. Oh, I'm biased. Okay, that's good. I can go for that. Okay, that's something I was going to get to. So I'm the grader. So what if I put all of the people who had the magical mint in a pile and all the people who didn't have a magical mint in another pile, and then I graded all the magical mint people, and I know that they were supposed to have been better. So guess what? They're probably going to be better because I'm kind of being a bad grader. Okay, so if I was blinded and didn't know who had the magical mint and who didn't, then when I graded those tests, wouldn't that be more fair? And then I would get more correct data? Okay. Go ahead. Yes, my basis is those people who didn't have the magical mint. And I'm going to compare. Well, I know, exactly. I don't have a baseline test, so I have to compare half of the class who didn't have the magical potion to half the class who did have the magical potion. And then I'm going to compare those results. So that is that control group that didn't get the magical mint is my baseline. Okay? But there's still one thing we're missing.
I always take 100.
Okay, but guess what? But you know what? Because I randomly put 15 people in here, and I randomly put 15, that's what I'm saying is that going into it, I know that your intellect is about the same across the group. I mean, on average, this group's intellect is about the same as this group's intellect. So going into it, I know that you're about the same intellect in both groups because I randomized it there. Okay? Okay. And I'm going to say not having anything is like having a dum-dum because you didn't get the magical potion. Holy cow, thank you so much. What if Hunter thought he was going to do better just because he got a magical mint? Yes. Okay, well, you should have spoke up. I didn't hear you. Okay, good. Okay, well, there you go. So Hunter knows and thinks in his mind that he's going to do better just because he got a magical mint. So what? So I need to redesign this, and maybe I should give half the class a magical mint and half the class something that looks like a magical mint, but it's really a placebo. Very good. So you all get a magical mint, and you all think that, or you don't know. Okay? And then we have the test, and then, so guess what? You don't know now, so you are considered blinded. So you don't know if you had the real treatment or the placebo. Okay? Now, okay, true. Exactly. Very good point. Whether you see, you didn't know if you had the real thing or not, and so guess what? Statistically, you will do 20 to 30% better just because you think you got the magical mint. That's the placebo effect. Okay, so you're going to do 20, 30% better just because I gave you a magical mint, but if the magical mints really worked, I would expect my group of magical mint people to not only be 20 to 30% higher because of the placebo effect, but even more so than the control group that had the placebo. Are we getting it? Okay, now, so you guys are blinded because you don't know which kind of mint you got, do you? I'm blinded because I don't know who had it, so when I grade, I'm not thinking this person should do better. So it'd be like, you know, Miss Timms or Miss Preston coming in here and going, and she predetermined, she randomized, she decided randomly who got the magic potion and who didn't, who gets the placebo. And so I say to Gregory, I say, okay, what's your name? Gregory. Okay, well then you get this one right here. And I don't know, that was Miss Preston doing that. I don't know, and Gregory doesn't know. Miss Preston is the only one who knows, and so she'll be my translator at the end. When I give her all the results, she'll have to translate it back. All right, are we good? Yes, double-blinded is because you don't know and I don't know, so we're double-blinded. Have y'all seen House? I'll keep up with that. And then the girl that's going through the Huntington's thing, and then, yes, and then Foreman, he was blinded. But then he suspected that she was getting the real medicine because she was feeling better. Well, what was that? Placebo effect. Okay. So then, you know, by accident, he found out that she wasn't really getting the real medicine. She was getting the placebo. And so he changed it out. And then that's, you know, what's the danger in that? That messes up the whole entire legitimacy of the experiment. So let's design this experiment. We got class 3B. Okay, I'm going to split you guys into two groups. Half the class goes here, half the class goes here. And this is the kind of diagram that will help you create an experiment. And then usually I like to make a diagram first and then I verbalize it. Some people are the opposite. What do I need to make sure that happens between splitting my class up in half? I need to make sure that I split you guys up how? Okay, so I need to, this is important. You need to put this in here. Randomize. I've even seen on some AP tests or in some grading keys that you need to say how you randomized. You would need to say, I'm going to give numbers, you know, give everybody a number, use a random number generator, and split them up that way. All right. Then, let's see. Then what am I going to do? I split you guys up, now what? Okay, good. I'm going to give the treatment. That's what it's called. I'm going to give the treatment. So a group gets an M to the 4th, but you know what? It was really a placebo. Another group gets M to the 4th, and it was the actual treatment. Okay. Now what? Aren't you going to take a test? You have to take a test. Okay. Then compare the results. Okay. All right. Very good. So that's how you would design that, and then you can go through describing it, and you would want to talk about all of those control things that we put into. We controlled what we could. We randomized the rest, and we repeated. How many? There's 30 people in here. How many times did I repeat? 15. Okay, because those people are considered repeats. All right. Next, let's do our Chapter 13 notes. And it has a lot of vocabulary in there, which we're going to be able to fill in now since we've all discussed it. Okay, let's go through the vocabulary. You ready? Yep, our Chapter 13 quiz is going to be next class period, and then we'll also spend half the class doing some practice AP problems in this area. Okay, if we were to observe individuals and record data without any intervention, we would then conduct a what? No. Observational study. Okay, that's what we were talking about at first today, observational study. I'm going to just watch the pregnancy and then see if you were drinking alcohol during it, how much you did, and put you in groups and decide what the results are. Observational studies can look at data that has already been collected. What would that be called? Very good. Retrospective. As opposed to looking at data as it occurs. That would be prospective. Very good. Okay. So, observational studies are valuable for discovering trends and possible relationships. That's about as good as it gets for an observational study, because you cannot demonstrate a what type of relationship? You cannot do a cause and effect or generalize to the population. Correct. If we want to examine cause and effect relationship, we must conduct a controlled experiment. Very good. Rather than an observational study. Okay, understand the difference between those two? Next, individuals on which the experiment is done are called, all you people who got the experimental units. Now, typically we refer to experimental units as non-people. I mean, that would be like the tomatoes or the dogs or the bumper or whatever thing it was that had the experiment on it. Because if they are people, we typically call them the subjects. You all are my AP subjects this year. So we're going to see how you do. The experimental condition that we apply to this is what? What's the thing? What was m to the fourth called? Will you hand that back there to Taylor? It's the treatment. Very good. So, treatment. The explanatory variable, okay, now we did not talk about this, but I think it's easy to stick this in right here. The explanatory variables, or the things that cause the change in the other variables, that's a factor. Okay? So, my giving you a candy or a mint or something, that was the factor. You can have these factors at different levels. Maybe I wanted to see exactly how much of the magical potion I needed to put in the mints. Maybe I wanted to see if I should put, 2 milligrams of potion or 4 milligrams of potion or 6 milligrams. So that would be the different levels. So I could do another experiment and break it down even further to between those people that I gave the mint to, see how much of the potion you need to have in order to do well. So that would be the different levels. When designing an experiment, we want to minimize the effect of what? So that our results are not biased. Minimize the effect of, oh, you don't know this word. It's really vocabulary. It's called lurking variables. Those, we actually were doing that during our discussion. Remember when we talked about don't compare your test to a tax score, and don't compare your class to another class, because there's lots of other lurking variables there. We maintained it, so we controlled our lurking variables. Because we may not be able to identify and eliminate all these lurking variables, it is essential that we use a control. The control group gets either no treatment or a fake treatment to counter the what? Well, yeah, I know. See, it shouldn't be that. It should be, we want to give them the fake treatment to counter the see, because when you get the, oh yes, well, when you get the fake one, then we're countering the placebo effect. That's right, because we're allowing you to not know if you had the fake one or the real one. But that's counter, so. I don't know. I've been thinking it's supposed to be this all along, and then when I read that word, I question myself, but we'll put that there. And or any other lurking variables present. Having a blank allows us to compare the results of a treatment. Having a controlled group allows us. Okay, that's pretty much it. We're going to skip this next little section on the design because we've already experienced that. But we remember that if we want to examine a cause and effect relationship, we conduct a controlled experiment. If a well-designed experiment, a strong association in the data, if it's a well-designed experiment, a strong association in the data will imply causation since any possible lurking variables were controlled. Remember, if we want to examine a cause and effect relationship, we conduct a controlled experiment, or just an experiment, because an experiment implies controlling. Okay, so here are the principles of the experimental design. We talked about these already. Control or minimize. You want to control the effects of all your lurking variables. You want to use what to assign subject or units treatments? Randomization, good. So you're going to control what you can, randomize the rest. Control what you can, randomize the rest, and then blank the experiment on many subjects to reduce variation. How about repeat? So, control what you can, randomize the rest, repeat it as much as possible so that you can compare all those. An effect is called blank if it is too great to be caused by simply by chance. Yes, that's right, I heard it. Statistically significant. I don't know, I can't. Statistically significant. Now, significant. Okay. And guess what? That's not a numerical value yet. We will learn later on this year, we'll assign an alpha value to it and go into all of that stuff. But at this point, you don't know, a numerical amount for that. All right. Even a well-designed experiment can contain what? So it's extremely important. Okay. Bias. So it's extremely important to handle the subjects in exactly the same way. Like you could have been biased if you knew that you had the thing. One way to avoid a hidden bias is to conduct a what? Well, if I blind you and you don't know which one you have, but in the next one, neither the subjects nor the ones who evaluate it. So this would be double blind. Very good. Okay, see, all that vocabulary you already knew just from our previous discussions. Okay, here are types of experimental design. In a blank, all subjects are just randomly assigned to treatment groups. I think it's just a randomized experiment, generally randomized experiment. Okay. In a blank, subjects are first split into groups called, oh, you know what, I don't think we went into this in depth, but I talked about it on the first page. In a blocked experiment, remember I said blocking is to experiments as what? Good. Stratifying is to sampling. So we're going to block. Okay, the example I gave, I think the medicine's going to have a different effect on men and women. So I'm going to block them into men and then block them into women and see what happens. Subjects are first split into groups called blocks. Imagine that. Subjects within each block have some common trait. Maybe they're all in the same general age. Maybe they all exercise the same amount each week. Maybe they're, the same gender, whatever. Then within each block, you're randomly assigned to the treatment groups. Okay. there's like too many blanks down here. I have no idea what else is supposed to be there, but I believe that this is supposed to be about this thing called a matched pairs design, and I want you to make sure that you cover that when you're reading in your text. It's not, I mean, it's used, but it's a pretty simple thing. You're just matching a person and another person that are almost identical, and like giving, you know, if you're testing a shoe, you're going to give one person in that pair the support shoe and one person in that pair the placebo shoe, whatever. So it has to do with that. Okay, that's it. We're going to skip that lurking and confounding. Lurking and confounding are typical, a similar way to get the vocabulary, those vocabulary mixed up, but it's not a big deal. We get out of here at, shoot, you need this assignment. Write this down. Okay, and I'm going to give you another piece of paper. I've had my other classes do a lab and Coke factual thing, but because I don't have time to explain that, I'm going to give you this. Design an experiment on this paper and do an AP write-up for, oh, then you need one more. So do those and this. Okay. This is like the ESP thing. What? The notes, yeah, you know what? That other page was a boo-boo on there. It was, the other page on the notes was Chapter 12 notes, and then that goes to that other table. So, yeah, there's nothing else to the notes. So you're good. Okay? All right, so we'll quiz on experimental design next time, and then review for the chapter or unit test.